In this lesson, I am dealing with trigonometric ratios of complementary angles. So basically, you are familiar with these terms trigonometric ratios and complementary angles. Before we talk about trigonometric ratios of complementary angles, we have to introduce in short what complementary angles are. For this, let us consider a right angled triangle. So basically we have a right angled triangle over here. You can see in this picture. One of this angle is 90 degree and other two angles make 90 degrees. That is, suppose this angle to be theta and this angle to be alpha. Then theta plus alpha is 90 degrees. So complementary angles are any pair of angles which gives 90 degree when added. So you can see two complementary angles in a right angled triangle, as one of its angle is right angle and the remaining two angles makes 90 degrees. So now let us define trigonometric ratios of these complementary angles. For this, let us consider a right angled triangle. So we have a right angled triangle in this figure. One of its angle is 90 degrees and suppose this angle to be theta, then this angle is 90 degrees minus theta, and we are dealing with trigonometric ratios of acute angles. So the longest side of the right angle triangle is the side opposite to the right angle, and this is called the hypotenuse, and side opposite to this angle theta, which is under consideration, is known as perpendicular. For this theta, this side is perpendicular, suppose this to be x, and remaining one side, suppose this to be y. Let us define trigonometric ratios for this angle, and then we will define the trigonometric ratios of this angle, that is 90 degrees minus theta, and then we see any kind of relationship between trigonometric ratios of this angle theta and this angle 90 degrees minus theta. So let us define. So sine of theta, that is sine theta, is defined as side opposite to this angle theta, that is x, and the longest side, that is hypotenuse. So it is x over h. Similarly, you can define cos theta, cot theta, tan theta, cosec theta, sec theta, and cot theta. Cos theta is defined as adjacent over hypotenuse, so it is y over h. Tan theta is defined as perpendicular over base, that is side opposite to the angle and the adjacent, so it is x over y. Cosec theta is defined as a reciprocal of sin theta, so it is y over x. Sec theta is defined as a reciprocal of cos theta, so sec theta will be h over y, and cot theta is defined as a reciprocal of tan theta, so tan theta is x over y, so cot theta will be y over x. Let us now define trigonometric ratios of this angle, that is 90 degrees minus theta. So let us start with sine. So sine 90 degrees minus theta is equal to Now this angle is under consideration. So the side opposite to this angle is perpendicular, that is y, and the longest side will not change, so it will be h. Similarly, we can define cos 90 degree cos 90 degrees cos 90 degrees minus theta, and cos 90 degree minus theta will be, now this is the opposite adjacent, so x, and the hypotenuse is h. Similarly, we can define tan 90 degrees minus theta. For this angle, perpendicular is y and base is x. Sec 90 degrees minus theta, cosec 90 degrees minus theta, and cot 90 degrees minus theta. You know, sec theta is reciprocal of cos theta. So cos 90 degree minus theta, sec 90 degrees minus theta is reciprocal of this cosec 90 degrees minus theta. So it is h over x, and cosec 90 degrees minus theta is reciprocal of this sin theta. So it will be h over y, and cot 90 degrees minus theta is reciprocal, cot 90 degrees minus theta is reciprocal of this tan 90 degrees minus theta. So it will be x over y. So we have defined over here trigonometric ratios of this angle theta and trigonometric ratios of this angle 90 degrees minus theta. But these two angles are complementary angles as their sum is 90 degrees. Now let us compare these trigonometric ratios together. What you conclude? Sin over theta is x over y, and cos 90 degrees minus theta is equal to x over y. So we conclude that, what we conclude? We conclude that sin theta is equal to cos 90 degrees minus theta, as they are x over y. So what you get? Sin theta is equal to cos 90 degrees minus theta, and cos theta is equal to y over h, and here you see that sin 90 degree minus theta is equal to y over h. So basically cos theta and sin 90 degrees minus theta are equal because their right hand side are y over h, y over h. So cos theta is equal to sin 90 degrees minus theta. Similarly, you can see that tan 90 degrees minus theta is equal to cot theta, and cot 90 degrees minus theta is equal to tan theta. Also, you can see that sec 90 degrees minus theta is equal to cosec theta, and cosec 90 degrees minus theta is equal to sec theta. So we have concluded that sine of alpha is equal to cos of theta if Sine of alpha is equal to cos of theta if alpha plus theta is equal to 90 degrees, that is alpha and theta are complementary to each other, that is they are complementary angles. Similarly, tan theta is equal to cot alpha if theta plus alpha is equal to 90 degrees. Once again, it is possible only when they are complementary. So we have learned about trigonometric ratios of complementary angles.